Hello everyone and welcome back to another Math Tutor Edu's lecture video. Okay, so let me give you a brief recap on what we have done in our previous lecture video. Okay, in our previous lecture video, we have just entered into a new chapter, which is the chapter 3 system of equations, okay, within the Form 4 syllabus, and we have briefly go through what are the subtopics within the systems of equation, and we have also discussed the new subtopic systems of linear equation in 3 variables using the substitution method. Okay, I have mentioned in my previous lecture video that I will be discussing a new method using the same example, okay, which I'm going to do in this lecture video, guys. Okay, so now what I'm going to do is I'm going to copy down this question. So I'm going to paste it over here. Okay, and from here we're going to continue to solve this using the elimination method, okay, the second method. Method 2, elimination. Okay, if you ask me personally, I will prefer the method 2 over method 1 because method 1 is longer. Okay, method 2 is faster, it's just that you need to be extra careful when you are doing the elimination. Okay, but if you do more practice, I'm sure that the method 2 will be your top preference. Okay, so let us discuss on how we can use the elimination method in order to solve this system of linear equation in 3 variables. Okay, so the concept is almost the same as the substitution method. From 3 variables you reduce to 2 variables, and from 2 variables you reduce to 1 variable. Okay, so from here, in order for you to perform elimination, you need to choose 2 equations. So which equation you want to choose? So from here we can choose the equation 1 and 2 to be eliminated. Okay, now which variable you want to eliminate? Okay, if you take a look over here, it is very obvious that z is the easiest one to get eliminated. So in the top preference we will choose the variable z. Okay, in fact you can choose any variable that you want. If you want to choose the eliminate, x also can, y also can. Okay, but in this case, for the convenience, we choose to eliminate the variable z. Okay, so what I'm going to do, so I'm going to rewrite over here. So using equation 1 and 2, equation 1 and equation 2. Okay, so from here 2x plus y plus z equals to 0. So from here 3x plus 2y minus z equals to 7. Okay, like I've mentioned, we are going to eliminate the z variable. Okay, so how to make sure that the z variable is completely removed? So these 2 equations we need to plus them together. So z plus with negative z, so from here get is 0. Okay, your z variable is gone. Okay, so from here, once you're done with this elimination of z variable, then proceed to the other variables. Okay, so from here 2x plus with 3x get is 5x, y plus with 2y get is 3y. Okay, and then 0 plus with 7 you get is 7. So from here 5x plus 3y equals to 7. So this is your fourth equation, and this is your first 2 variable equation. So make sure that you highlight this. Okay, usually what I do, I'll box this so that it will be easier for me to conduct in the upcoming working. Okay, so from here 5x plus 3y equals to 7. So this is your equation number 4. So we still need one more equation for us before we can proceed to the next step, is the reduction of the 2 variable to 1 variable. So we need one more equation, right? So for the one more equation, we can use equation 2 and 3 to perform the elimination. Okay, so from here using equation 2 and 3, okay, so from here 3x plus with 2y minus z equals to 7, 4x plus with y minus with 5z equals to 22. Okay, one thing you should know, once you start with eliminating the z variable, even in the below equation also, you must be consistent, guys. You must eliminate the z variable as well. Okay, if you don't eliminate the z variable, it will be wrong. Okay, so from here, if you want to eliminate the z variable, so what you need to do, so there is only one possible way. Okay, you times the whole equation by 5 in this case. Okay, this equation you times the whole equation by 5. Okay, and then continue with the next step. So from here, 5 times 3 is 15x plus with 10y minus with 5z equals to 35. Okay, by the way, it's not 52, guys, it's actually 5z. Okay, then 4x plus with y minus with 5z equals to 22. So these two equations, now we can perform the elimination. So how are you going to eliminate the z variable? Okay, so we're going to eliminate the z variable by minusing the two equations. So equation 2 and 3, so we're going to minus them together. Okay, negative 5x minus with negative 5z minus with negative 5z, so from here you get is 0. Okay, 15x minus 4x, you get is 11x. 10y minus y, you get is 9y. 35 minus 22, you get is 13. Okay, so this is your equation number 5. Okay, so let me box this. Okay, just give me a moment, let me box this. Okay, so now we have already successfully reduced from 3 variables to 2 variables. Okay, only that particular step that you need to be careful. Okay, so let me recap again. At the beginning, we choose the equation 1 and 2 to eliminate the z variable, and then for the next step, we use equation 2 and 3 to eliminate the z variable. Okay, because remember, guys, 2 equation, 2 variables. Okay, so we have already successfully finished the first step. Okay, now within this 2 equation, 5x plus 3y equals to 7 and 11x plus 9y equals to 13. So we're going to proceed to the next step, is by reducing the 2 variable to 1 variable using the same elimination method. Okay, so from here, 5x plus with 3y equals to 7, 11x plus with 9y equals to 13. So this is equation number 4 and this is equation number 5. Okay, so from here, which equation you choose to eliminate? Okay, if I were you, I would prefer to eliminate the y rather than x. You can still eliminate x, but the steps will be longer. Okay, so 3 and 9. So how can you eliminate the y variable? The equation 4, you just times with 3. 3 times 3 you get is 9. So 9 and 9 you can easily cancel them out. Okay, so it is easier for us to eliminate the y rather than eliminating the x variable. Okay, so from here, let us proceed to the next step. So 5 times 3 is 15x plus with 3y times with 3 is 9y. 7 times 3 is 21. Okay, and then this equation 5 remains the same, 11x plus with 9y equals to 13. Okay, so now these two equations you can minus them by eliminating the y variable. Okay, y is automatically cancelled off because 9y minus 9y is 0. Okay, so from here you only left with x variable and the numbers. So 15x minus 11x is 4x. 21 minus 13 is 8. 4x is equals to 8. So to get x, what you do, 8 you divide with 4. So from here you get your x is equals to 2. So this is your first solution. Okay, so once you get your x value, So now you can use this x value and substitute into either one of these two equations. You can choose to substitute either equation 4 or equation 5. Okay, so in this case I prefer to substitute into equation 4. Okay, when x equals to 2, 5x plus with 3y equals to 7. Okay, you substitute the 2 over here, so 5 times with 2 plus with 3y equals to 7. So from here 3y will be equals to, so this 5 times 2 will become 10. So the 10 from left hand side you move over right hand side will become negative 10. So negative 10 plus with 7 will be negative 3. So 3y equals to negative 3. So to get your y, what you do, negative 3 divide with 3. So from here get your y is equals to negative 1. So you already get the second solution. Okay, we have already find the x, we have already find the y. Can we find the z? Yes, we can. So to find the z variable, you can choose either one of these equation, okay, to find your z variable. So from here we choose to substitute into the equation 1. Okay, so when x equals to 2 and y equals to negative 1, so from here let me just check. Okay, 2x plus y plus z equals to 0. So 2 times with 2 plus with negative 1 plus with z equals to 0. So from here 4 minus 1, 2 times 2 you get is 4. Okay, plus with negative 1 you get is 3 plus z equals to 0. So from here you get your z is equals to negative 3. So this is your third solution. Okay, by the end of this working you will find out that you will get the same answer regardless of you using elimination method or substitution method. Okay, the method doesn't care provided that your working should be correct. Okay, you see, you get the same answer. Alright, so that is all for our lecture video for today. So I hope you have understand the elimination concept. So if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AdMaths lecture videos in the future, and not to forget to share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.